Hey Algebra 2. So this video we're going to learn about matrix multiplication. And there's really two types of multiplication we're going to learn. The first type is just multiplying by something called a scalar. And the second type is if we're actually going to try to multiply two matrices together. So this first type, we're on page 100 in the binder, so make sure you get yourself there. A scalar multiplication is when we multiply by some number that we call a scalar to every element inside the matrix. And what do we mean by a scalar? Well, it's just sort of a name used in math to represent a real number that's not in a matrix, or there's some other places in math where it's used as well. But so like here in problem A, we have k times this matrix. K is considered a scalar, and you just distribute it to every single element in the matrix. Same with problem B here. So it's 3 times the matrix 3, 5, 2, 8. So I'm going to take the 3 and multiply it to every single element of the matrix. So you get 3 times 3 is 9, 15, 6, 3 times 8, 24. So if we practice that, we would have, let's see, example 1, negative 3 times that matrix. So I'm going to multiply every element in the matrix times negative 3. So negative 45, 36, negative 30, 0, and then negative 60, 30, negative 21, 0. In example 2 here, it's actually saying do 5 times A minus 3 times B. So if I do 5 times A, I'm going to get the matrix 10, 15, negative 35, 5, 20, 25. And then it says to do minus 3 times B. So that's going to give me the matrix 9, 0, 18, negative 3, 24, 6. I multiplied every element in matrix B by 3. Now I just do the subtraction like we did the other day. 10 minus 9 is 1. 15 minus 0 is 15. Negative 35 minus 18 would be negative 53. Then 5 minus negative 3, 8. 20 minus 24, negative 4. 25 minus 6, 19. Okay. If we're going to solve one of these equations, we do the same thing. We try to get x alone. So here I would, in example 3, multiply the matrix by 2. So I would get the matrix 6, 8, negative 4, 2. And 4x. And now I would subtract that matrix from both sides. To get 4x equals 10 minus 6 is 4. 0 minus 8 is negative 8. 4 minus negative 4 is positive 8. 2 minus 2 is 0. And then I would just divide by 4. And that's a scalar. We're really multiplying by 1/4. So my x matrix is 4 divided by 4, 1, negative 2, positive 2, 0. Let's go on to the next page. On this page here, we've got kind of a step-by-step, and I'm actually not going to read through this. If you want to read through it to after you watch the video to maybe hear it explained a different way, you can, but there is one important part that I'm going to talk about on this page, and that's the very top. So if I'm ever going to multiply two matrices together, okay, there's sort of a rule we have to follow, and it says the product A times B is defined only if the number of columns in A is the same as the number of rows in B. Okay? And like that looks kind of complicated, so let's take a look at what it really means. And so if I'm going to rewrite these two matrices. So we have this one is 1, 2, 3, 4, 5, 6. And this one is 7, 8, 9, 10, 11, 12, 13, 14. So if you're trying to decide if you're able to multiply two matrices together, you got to write the dimensions of both. So this one is 3 rows by 2 columns. Okay, and then this one is 2 rows by 4 columns. So what you always look for is these have to match. Right, the inside numbers, which is really the number of columns of the first and the number of rows in the second. They got to be the same. And if they are, then the outside ones, 3 by 4, that's going to be your new dimensions, or result, the product's dimensions. Okay, so let's do a couple examples on the next page. So here we go. We have let A equal that matrix, B equal that matrix, find A times B. So we're going to start with the dimensions. This is 2 by 2, this is 2 by 2, and so the insides match, woohoo, and the outsides are going to be the result. So we're going to have a 2 by 2 matrix as the answer. Okay, so then how do we actually multiply? The way you multiply is essentially you take a row times an entire column. And what do I mean by that? We're going to take the very first row of A and multiply it by the column B. And we call this thing an inner product. That's one name of what that's called. Inner product. Okay, and the way that works is you do -1 times -3. So that's the first element of each, plus, then you do 2 times 5, the second element of each. Okay. So what does that equal? That is 3 plus 10, so that's 13. Okay. So we know we're going to get a 2 by 2 matrix, right? All right, well, and you're probably still getting used to that idea. That's what's going to happen. So there's 4 spots we have to fill in. What I like to point out is we just did the top times the left. Top times the left, guess where we put that number? The top left. Okay, so that number goes right there, 13. Okay, now we're going to do the top times the right. So I keep looking at the -1 and the 2 in the top, but now I'm going to move on to the right, the 3 times the -2 there. So I get -1 times 3 plus 2 times -2. Okay, let's look at that again. It's -1 top times 3, and then 2 times -2. Right? That's the inner product of the top and the right. And what do we get? We get -3 plus -4, which is -7. So on the top right, I get a -7. Okay, and then we kind of move on to the bottom row of the first. If I want to fill in the bottom left, I need to multiply the bottom times the left. And it's always first times first plus second times second. So we would have 3 times -3 plus -4 times 5. That gets me -9 minus 20, so -29. So the bottom left is -29, and then we finally end up with the bottom and the right. Okay, so do your inner product there. 3 times 3 is 9, plus, it's always addition, and then -4 times -2, equals, that's going to be 9 plus positive 8, so 17. Bottom right is 17. Okay, there's our first one. Let's try another one. We have to do a few of these and it's going to start to kick in a little bit. Okay, so I'm going to rewrite them. We have, this time we're doing b times a. Okay, so let's write b first. Negative 3, 3, 5, negative 2 times a is negative 1, 2, 3, negative 4. Okay, b times a looks like this. Okay, and maybe I'll try to do this a little, organize it in a different way to help you guys see it. So I know it's 2 by 2 times a 2 by 2. Okay, the insides match there, and my result's going to be a 2 by 2. So once again, I have those 4 spots I have to fill in. Okay. So let's do this. We're going to do the top left. So in order to find the top left, I'm going to multiply the top by the left. Okay, so let's look at this as negative 3 times negative 1. So we have negative 3 times negative 1 plus, and then 3 times 3. And that ends up equaling 3 plus 9, which is 12. Top left. So maybe pause it and try doing the top right, and then the bottom left, and then the bottom right. And I'll kind of work through it quickly while you do that. How'd you do? So one thing to notice here is we just did a times b and b times a. And so is multiplication commutative, matrix multiplication commutative? Well, did we get the same answer both ways? No. And so matrix multiplication is not commutative. All right, to finish up here, let's look at examples 7 and 8. So in 7, we're supposed to do c times d. Well, let's see if we can even do it. We have a 1 by 2, 1 row, 2 columns, by a 2 rows and 3 columns. Okay, the insides match, good. So I'm going to get, the result is a 1 by 3. Okay, so here I'm going to do I just have to do, there's no top or bottom, it's just column times left. And so we do the inner product there and get 3 times 4 plus negative 5 times negative 2, which is 12 plus 10, so 22. And then I have times the middle, and that's going to give me 3 times 0 plus negative 5 times 7, that's going to be negative 35, and then times the right, which should give you 3 times negative 1 plus negative 5 times 3, which is negative 3 plus negative 15, negative 18. Okay, there's my answer there. Find d times c. Okay, so let's rewrite it. 4, 0, negative 1, negative 2, 7, 3, times 3, negative 5. Here we have 2 times 2 by 3 column, 2 by 3 matrix times a 1 by 2 matrix. Uh-oh. Those don't match. So we actually can't do this multiplication. We say this is undefined. Or like we said the other day, not possible. Okay, and so there we go. That is matrix multiplication. Thanks for watching.